Hello. Welcome to this session where we are a kind of a boxing with 3-point estimates. So was my internal terminology by saying that we are going to discuss about 3-point estimates, encoding them, calculating risks, and understanding how these 3-point estimates are used in project risk management. Let's assume that we have a very simple project, for example, delivering this kind of a flipboard stand. And we have a task to make a cost estimate of this project. And we do it by giving the values, several values for the cost that we are going to expect that might happen or realize in the end of the project. And we provide the minimum value, 150 euros. We provide the maximum value, 600 euros. And the most probable value, 250 euros. And we have just these three values here. So we have a 3-point estimate. We could as well use this kind of estimating to estimate the duration, for example, project duration or activity duration in days, or we could use that for estimating man hours, so not necessarily only cost. When we have given these three values, we have considered qualitatively and by discussing within our project team that the material prices, man hours spent, and the estimate uncertainty in these are the reasons why this cost variation might happen. So we have concrete risks also identified that we can do something about if we like. For example, to reduce the variation in costs and so on. So of course we cannot affect the costs only, we must affect something that is the source for these costs, and we know these sources and we have been discussing them vividly when providing these estimates. So these three estimates can be used as parameters of a probability distribution, a skewed probability distribution with a long tail towards the unfavorable side. So there are quite many unfavorable things that might happen that might take the cost further away from the most probable value, but there are not so many such events that might bring us cost reduction significantly. So there is a kind of a limit in the favorable side, and this is what makes the form of this distribution skewed. Now, in this picture, we have calculated the expected value of this probability distribution and the standard deviation by using the formula shown in the picture. And where is this approximation of the mean value and the standard deviation based on? So we have used the PERT method, program evaluation and review technique, which allows for using stochastic estimates, these 3 points that are assumed to be parameters of a beta distribution. And with that estimation or assumption of having a beta distribution form, these approximations, they work quite well. So maybe we can be rather satisfied that the expected value and standard deviation calculated with this formula is quite good, especially in terms of comparing it to the accuracy of how we can subjectively express the minimums, maximums, and most probables based on our expertise and opinion. Okay, now In this picture, we take this risk analysis of this flipboard stand even further. Now, in the table that this picture shows, this 3-point estimate that I just showed to you is used only as a basic estimate that includes those man hours and material price and estimate uncertainty things or risks considered as sources for variation. But then we have recognized that there are other risks that we should also consider and calculate for our project. For example, we might need to build this flipboard stand outdoors, and the weather conditions are a significant risk. And we have estimated the minimum -50. So please note that there is a favorable potential outcome of cost reduction of 50 euros due to weather conditions. But then the most probable value of weather conditions is 0 and the maximum is 150, another skewed probability distribution. Then attitude of the customer, staff motivation. How do we then go on when we have these 4 risks or 4 probability distributions that we assume as independent? That is one important assumption that we make here by calculating the total risk from these component parts of the project risk. So we calculate the sum of those mean values of those probability distributions, and we get the mean value of the total risk distribution. Then we have calculated the variance for each distribution by putting the standard deviation in the power of 2, calculated those variances together, and then taking the square root, and we have ended up that the total distribution standard deviation is 100. Okay, now we have the parameters of the total risk distribution. Let's see. 379 is our mean value or expected value. We can make a bell-shaped probability distribution around it. And now our assumption is that the total risk is distributed according to the normal distribution. So if we mathematically try to justify it, we would say that the central limit theorem brings quite quickly with only few part distributions which are skewed the end result, which is normal distributed. Okay, we go one standard deviation further from this mean value, and we have 479, which represents roughly the 86% fractile. And if we go again another 100, which is the standard deviation further from the mean value, we are about at the level of 98% of not exceeding that cost. And this bell-shaped curve can also be drawn in a cumulative probability distribution format. So a normal distribution which has the same information here. In the next picture, I show this cumulative probability distribution. And how can we use this total risk distribution? Now in this picture, we have marked few fractals, for example, 10%, 70%, and 90% fractals. And for example, if we want to, for example, set the budget to 379, where there is 50-50 chance of going over or coming under this mean value, then we could set a contingency of 52, for example, to come up to the value 431, representing the 70% of fractal. So we are on the kind of a safe side with that kind of a contingency. So there is 70% probability of not exceeding that cost. And now the interesting question would be that if we needed to sell this project to a customer, so what would be the sales price? So what kind of a price would be success to the customer? Of course, we have now the probabilities here and all the values. So would we like to be on the safe side and sell it for 600 or sell it for even much higher volume? Or are we so hungry of getting the deal that we want to take the risk and sell the project for 250? For example, being in the 10% fractal and take a significant risk of exceeding even that revenue that we get from the customer. Well, now I take this table again up, which we looked a while ago, and I tell you the following practical example and my great experience of using this method. When I was working in industry, we were using this method for evaluating of a water power plant, hydro power plant bid to the customer. So instead of having this weather conditions attitude to the customer and intangible risks, we evaluated the water turbine, the generator, mechanical processes and piping, and electrical systems. By providing all these physical or functional parts of the project, minimum, most probable, and maximum estimates with justification. And actually, this all was a teamwork where there was a guy that had made the water turbine design and the kind of a purchase documents of that water turbine from a contractor. There was a guy representing the generator and the generator estimate. Then the guy from the kind of a mechanical process department and the guy from the electrical systems department that had participated in making the bid. And then there was the business unit director who was in charge of releasing this bid and making a decision together with this team that whether we should really bid to the customer. Using this method, it took only 1.5 hours of gathering these people to a meeting room and taking this kind of a flipboard and having them together to discuss about various risks and providing the minimum, most probable, maximum estimates. And what happened in that meeting was that quite many risk mitigation actions were planned, and also the risk estimates were adjusted. But maybe the most important thing was that when the water turbine person originally provided his estimate of minimum and maximum being quite far from each other, and the variation being quite big, so indicating a big risk. So the business unit director reacted very strongly to that and asked that why there is so big cost variation, why the risks are so big. And the explanation was that this water turbine expert was using a rather cheap supplier with risks of having quite low quality even, and maybe risks of adjusting the water turbine on site even if the quality is not right. And the business unit director made there in that session a decision that we cannot take this kind of a risk, but we must select a more expensive water turbine, and we must be on a safe side of knowing what it's going to cost. And it was not only the cost, but it was all these potential quality problems. To avoid these kinds of quality problems, pay a little bit more and avoid risk. That was actually the learning of that session, and decisions about how to mitigate the risks and how to avoid, in this case, non-qualified water turbine supplier. So they were made in that meeting. So what I try to underline here is that this method is really a kind of a group work method. It doesn't take more than 1 hour or 1.5 hours. Just take people in the same room and use these quantitative estimates to facilitate the discussion and understanding about risks, and really making some real decisions about what to do with those risks. The estimates that we have derived by this method, these 3-point estimates, they are kind of a subjective estimates that are provided by a very knowledgeable experts that have planned the project and who know the project very well, and so on. But we cannot use the frequencies from the past, and therefore we must use these people's opinions, which means that the opinions are not bad, but because they have a great expertise. But still, human beings are not very good estimators, and these estimates are subject to various kinds of biases. For example, people might be very overconfident about their estimates. There might be optimism, there might be groupthink, and so on. And especially when producing the 3-point estimates, one phenomenon that very often happens is that the people anchor to the first value. For example, if we provide a value of 250 euros, so that serves as an anchor, and people cannot see a variation very far from that anchoring value. And this is why, for example, often facilitators are needed for these kinds of group sessions, where the facilitators tries to persuade people really to get their mind away from these kinds of anchors and overconfidence and other kinds of biases, so that we can get realistic and, let's say, big enough maximum values, and maybe small enough minimum values, so that we are not stuck only to one figure. Well, one interesting thing that I still want to underline here is that the risk and uncertainty gets intertwined in these estimates. So what do people estimate when they estimate the minimums, most probable maximum values? Are they estimating the real variation in nature, what the project is going to cost? No, not necessarily. But they also are estimating their own level of knowledge. So they are estimating how much they know. But again, human estimators are not very good at knowing how much they know or how much they don't know. So when they express that in a kind of a maximum and minimum values, so it again maybe needs a kind of a facilitator to help people to get out of constraining biases and heuristics in their mental systems. In this picture, I want to talk or underline a little bit the aspect of favorable and unfavorable side of events that might happen. At the top part of this picture, we have depicted a pure risk, which can be, for example, fire on site. And that is really an unfavorable event. That is kind of an on-off event that has a really small probability of occurring. So if we have, for example, 0.0001 probability of losing 1 million euros for fire, then there is also the assumption that there is 0.9999 probability of not having fire. So this is kind of the favorable side. But if we use this kind of an approach for estimating, for example, the building of this flipboard stand, which is a business risk issue, actually, what the costs will be and why. So if we, for example, express just the unfavorable figure of 600 euros about this flipboard stand building being a risk, then my question would be, if this has a probability of 0.01 of losing 600 or ending up to the cost of 600, so what about the rest of 0.99%? And therefore, at the lower part of the picture, so I have depicted the 3-point estimate of minimum, most probable, and maximum, which actually covers all the possible values, also including the favorable side of the outcome of this flipboard stand project. And when we compare these estimation practices by, for example, to the probability impact matrix, which is at the right top corner of this picture. So what we put in these kinds of matrices, we actually put in these kind of matrices only the unfavorable sides of the risks. And then the question is that is it fair or is it symmetrical? And does this kind of a risk management enhance our aspects of really putting our effort on taking advantage from the favorable sides and opportunities in projects? Or is our project risk management then, if only unfavorable events are identified and evaluated, is it only about hedging against the bad and not taking advantage of the good? Okay, this was all that I wanted to say. Thanks for being part of this session. So thank you. See you later. Bye.